So we have studied the concept of derivatives for multivariable function. And whenever we are talking about partial derivative of a function with respect to variable x, it is in the direction of x-axis. Whenever we are talking about partial derivative of a function with respect to y, that derivative is in the direction of y-axis. So now we are going to talk about directional derivatives of a function of two variables. Directional derivatives mean we are calculating derivative along a particular direction. So let us start and see what that actually means. So let us start. If z is equal to f of xy, the partial derivatives f1 prime xy and f2 prime xy measures the rates of change of fxy in the direction of x-axis and y-axis respectively. That we have already seen. Okay. So now let us look at other directions. So let me consider a function of two variables x comma y. Okay. Obviously, if I have a function of two variables, it has a domain. So consider a point in the domain. So consider x naught, y naught in the domain of f. So we are considering this particular point. So obviously, if you see if x comma y is any arbitrary point on the domain and x naught, y naught is a particular point in the domain, the direction of this vector, the direction ratios are given by x naught minus x and y naught minus y. Okay. So, or we can say x minus x naught, y minus y naught. So direction of a vector are always the final point, coordinates of the final point minus coordinates of the initial point or vice versa. So this is the direction vector of any 2 points lying on the line. Okay. Now suppose I want to find out the derivative along a point or along a vector h comma k lying on this line. Okay. So see what are the direction ratios of h comma k. So if you can connect h comma k to origin, the position vectors are given by h minus 0, k minus 0. So that means the direction of this is hk. Now, if I want this hk to lie on the line joining xy and x naught, y naught, what should be my situation? The direction should be proportional to each other. So that means x minus x naught upon h should be equals to y minus y naught upon k. Okay. So that is how direction ratios are proportional. And suppose this is equal to t and where t is a constant. Okay. So then I can always write x minus x naught upon h equals to t and y minus y naught upon k equals to t. So x can be written down as x naught plus ht and y can be written down as y naught plus kt. So my function now x comma y, if I talk about the direction hk, can be represented as f of x naught plus ht, y naught plus kt. This is my function now. Okay. And now we would like to calculate the directional derivative along the direction h comma k. So let us see how that can be achieved. Okay. So we have just seen that how I converted my function of x comma y to this particular point. So any point lying on the line will be joining x naught, y naught and h comma k can be represented like this. Okay, obviously hk should not be equal to 0, 0 simultaneously. So now what is the directional function? So my directional function, my fxy, you could see that it got converted into f of x naught plus th and y naught plus tk. So obviously here x naught and y naught is a particular point. So it's a constant point. So it does not change. Okay. So it does not change and h comma k is a given direction. So it also does not changes. So therefore this becomes a function of t and that is my function that is known as directional function. Okay, so this is my directional function. It is a function of one variable t because I've already told you that x naught, y naught, h comma k are constant. So let us try to find out the derivative of this particular directional function with respect to t. So g dash t will be, now I will be differentiating f with respect to the first variable, that is x naught plus th is my first variable. This is my variable 1 and this is my variable 2. So f1 prime xy dx by dt plus f2 prime xy dy by dt. This is according to the chain rule. Now f1 prime means I am differentiating with respect to the first variable, that is x, which is x naught plus th. So I can write it as f1 prime x naught plus th, okay, comma y naught plus th, and now x is a function of t. So what is my x? X is x naught plus th. So dx by dt will be h, and this will be f2 prime x naught plus th, comma y naught plus th. And what is my y? Y is y naught plus th. So dy tk, and so dy by dt will be equal to k. Okay, so this is my expression for g prime. Okay, so this has become the expression for g prime. And now let t is equal to 0. Then I will have g dash 0 equals to f1 dash, okay, x naught y naught h plus f2 dash x naught y naught k. Okay, so this is how we calculate the values. Now let us see what they are trying to say. So now this is called the directional derivative. Okay, now when are we going to have a directional derivative? Let us understand the condition. Now the condition is, for the case when the vector hk has length 1, the derivative of f in the direction hk is called the directional derivative of f in the direction hk at x naught y naught. So what is my condition? The condition is that my magnitude of h comma k should be equal to 1. What is the magnitude of a vector? A magnitude of a vector is its length. Okay, and now why are they taking the length to be unity? They are taking the length to be unity to avoid replication. Okay, so we might have a lot of parallel vectors in the same direction with different magnitudes. Okay, so what is the directional derivative? So if you want to talk about directional derivative in the direction hk, the vector hk should also always have magnitude 1, and you have to fix a particular point x naught y naught. Okay, and what is the technical representation of a directional derivative? So it is dhk fx naught y naught. So where x naught y naught was the particular point in the domain of f, h comma k represents direction, and we know that mod of h comma k will be 1. That is this particular condition which we have already discussed. Okay, so this is our directional derivative. Okay, so let us try to do some questions for illustration. So for example, look at example 16.5. Let fxy is equal to x comma y. So fxy is equal to x comma y. Compute the first and second directional derivative of f at x naught y naught in the direction hk is equal to 1 by root 2, 1 by root 2. So I'll be just calculating the first order directional derivative. Okay, so what is your direction? So h comma k is 1 by root 2 comma 1 by root 2. Okay, this is given to you. And what is your point? X naught, y naught. So it's okay. So h comma k, let us first confirm that h square plus k square is equal to 1. So 1 by root 2 square plus 1 by root 2 square is going to be 1 by 2 plus 1 by 2, that is equal to 1. Now let us calculate f1 prime. F1 prime means the derivative with respect to the first variable, that is y. Then what is your f2 prime? So f2 prime is the derivative with respect to the second variable y, that is x. So this is my f1 prime, this is my f2 prime. Okay, so the directional derivative in the direction h comma k, so and f at x naught y naught. So this is directional derivative in the direction 1 by root 2, 1 by root 2. F of x naught y naught is f1 prime x naught y naught h plus f2 prime x naught y naught k. So what is f1 prime? So f1 prime is y, and we are talking about the point y naught. So it will be y naught into 1 by root 2 plus x naught into 1 by root 2. So that is 1 by root 2 x naught plus y naught. And now x naught comma y naught is a point in the domain. So x naught can y naught can be any points in the domain. Give them values and find out the directional derivatives. Okay. Now let us look at the second point, that is hk 1 by root 2 minus 1 by root 2. So again we have to do this direction. Okay. And we have to do f at x naught y naught. So that is f1 prime. So f1 prime was y. So that is y naught into h plus f2 prime, that is x. So that is x naught into minus 1 by root 2, because k is minus 1 by root 2. So in this particular case, it will be 1 by root 2 y naught minus x naught. So this is how we can calculate directional derivative of a function at a point in the domain along a direction hk, where magnitude of hk will be 1. Magnitude means the length of the vector is equal to 1. Okay. Now let us talk about the second order derivatives. Okay, let us finish this. So now what was my GT? My GT was, if you remember, it was f of x naught plus th comma y naught plus th. Okay, this was my GT. And when I calculate the derivative of GT, that was f1 prime xy h, okay, plus f2 prime xy k. Okay, so where x was x naught plus th and y was y naught plus th. So this is my first derivative. Okay, now I want to find out the second derivative. So let us see. So if I talk about the second derivative, so g double prime t will be equal to d by dt of f1 prime xy, and h is a constant, plus d by dt of f2 prime xy, and then k is a constant. Okay. Now let us look at the right hand side. We are differentiating f1 prime with respect to t. Now f1 prime is again a function of two variables. So what do I do? Okay. So it is, when I'm differentiating with respect to t, I'm going to apply the chain rule once again. So now I differentiate f1 prime with respect to the first variable. So f11 dash xy. Okay. And then I have to differentiate x again. So that is your dx by dt. Then the chain rule says now differentiate it with respect to the second variable. Okay. And then it is dy by dt. And then there is an h outside. Similarly, if you differentiate f2 prime with respect to t, so first you differentiate f2 with respect to the first variable, okay, and then do dx by dt, and then you differentiate f2 prime with the second variable, okay. So the symbols will be double, okay, and then you do dy by dt as per the chain rule of derivative. Now we already know that dx, so what was my x? My x was x naught plus th. So this implies that dx by dt was h, and my y naught was y naught plus th. So this implies that dy by dt will be equal to, this is tk, will be equal to k. Okay, so these two things I know. Also, as per Young's theorem, okay, as per Young's theorem, if the partial derivatives are continuous, then F12 this will be equal to F21 this. Okay, so what we will do now, so this will be replaced by H, this will be replaced by K, this will be replaced by H, this will be replaced by K, and this will be same. So I will be writing G double dash T, that is the second derivative of T, that will be equal to F11, that is the partial derivative with respect to x 2 times, okay, xy h square, h into h, okay, plus then the F22 prime, okay, that is del 2y by del y2, something like that, xy into k into k, this is k into k, k square, and then F12 and F21 are same. So I can combine these two terms. So F12, okay, double prime. So, and this is KH. So this is 2 times HK. So G double dash T is F11, okay, XY H square plus 2HK F12 double dash XY plus k square F22 double dash xy. So this is the second order directional derivative in the direction hk. That is how we calculate, and now we can attempt a question on second order directional derivative. So let us do the same question part 1 again. So we have fxy equals to xy. Okay. So if you look at f1 prime xy, that is y. If you look at f1, 2, now differentiate it with respect to the second variable, that will be 1. And if you look at this, differentiating again with respect to the first variable, that is 0. f2 prime xy was differentiating with respect to y, that is x. Okay, and you can see that f21 double prime xy will be 1 because now I'm differentiating with respect to the second variable. F22 double dash xy, now I am differentiating this x with respect to y, that will be 0. So what is my directional derivative? Okay, so F11 dash 0 into h square plus 2hk, then you have to do this thing into 1 plus F22 dash, which is 0, and into k square. Okay, so my second order derivative, directional derivative, is nothing but 2hk. Now hk is 1 by root 2 into 1 by root 2, so that will be 1. So this is how you calculate directional derivative of a function of two variables at a particular point in the domain along a direction h comma a, such that the magnitude of that direction vector is equal to 1. Thanks a lot.